Okay, in this video, we're going to look at kinetic energy. I know the last video was a little long talking about work, but there's a lot of little things that go along with work that you do have to account for. And so here, let's talk about kinetic energy. So you just have to remember that this is kind of that physical science definition as well. So when you exert a force on an object over a distance, you're increasing the object's kinetic energy. Okay. We'll get into that there is a connection between the two. And so remember the simple definition of kinetic energy, it's just simply the energy of motion, right? Anytime you see that prefix K-I-N-E, right, it goes back to motion, right? So movement, kinesthetics, kinematics, kinesiology, that's all a study of motion, right? And so the symbol for kinetic energy is K. Sometimes you'll see it abbreviated KE, right? Simple enough, kinetic energy. The equation is K equals 1/2 mv squared. So 1/2 mass times velocity squared. And then the unit is joules, okay, which is abbreviated J. Remember, all energy has the unit of joules in here in physics. Okay. So one thing to note is that kinetic energy can never, ever be negative. There really is two reasons, right? One is that if you look at the equation, you're squaring the speed. So even if we were heading in the negative direction, because we're squaring the speed, that number always ends up being positive. And one thing to note that energy is a scalar quantity, okay? So work is a scalar quantity. And yes, we talked about work can be positive or negative, but that really has to do with the effect of what's going on with kinetic energy. Okay? So kinetic energy, the second reason is that kinetic energy does rely on mass, right? So if you look at the two things in the formula, mass and speed, well, this cannot be negative, right? Mass cannot be negative and speed cannot be negative. Okay? I don't know why I just wrote that up there, but so just remember that if you look at the two things in the equation, mass cannot be negative, velocity, and we're squaring the velocity, which makes it a positive number. Okay. So let's go through a couple questions or examples using kinetic energy. Right. So this is a 3,900 kilogram truck is moving at 6 meters per second. What is the kinetic energy? What is the truck's kinetic energy if its speed is doubled to 12 meters per second? All right, so A, right, this is just a straight kinetic energy calculation. So 1/2 mv squared. So 1/2, we have a 3,900 kilogram truck traveling 6 meters per second squared. And so we'll get a kinetic energy of 70,000 joules. Okay, that one's pretty simple, right? So we're just plugging in there. Now, part B, you have a couple ways that you can go about this, right? They do give you the speed, so you can do a straight calculation, right? So you just do 1/2 3,900 times 12 squared, right? And so then you would get an energy of 280,000 joules. But there is another way that you can do this, because this is where it runs into things like conceptual-based questions, or for OnRamps course in the learning catalytics, where they'll talk about these relationships, right? So it talks about the speed is double, right? And so there is a method called factors of change. Okay, and the factors of change method, basically what happens is you're going to plug in a 1 for everything that remains constant, and then the factor of what changes, right? And then you're going to solve for the unknown, right? So our unknown is actually K. So the 1/2 won't change, so we'll leave that as a 1. It's the same truck, so we'll leave that as a 1. But note that we double the speed, okay? And now something you'll notice is that here with the speed, right, it's speed squared, okay? And so what happens is when you square the speed, your kinetic energy becomes 4 times greater, okay? And so what happens is if 70,000 joules is, excuse me, is our original kinetic energy, all we have to do is multiply that by 4, and we'll get the same answer of 280,000 joules, okay? So this factors of change method will help out with that. And I'll do a separate video just addressing the factors of change. And I'll make sure that gets uploaded to YouTube and to our various platforms, okay? But it just helps you to determine what is the factor that pops out, okay? Sometimes teachers, in the past I've taught just plugging in a 2V for the velocity, and then you'll see that the 4 pops out. But that's just a method, right? So you don't necessarily have to do the straight calculation. You can just figure out how much times greater is the new kinetic energy going to be, and then multiply it by the original, okay? Now the next one, here's one we're going to actually solve for mass. So this tells us that the kinetic energy of the boat is 15,000 joules, and now the boat has a speed of 5 meters per second. What is the mass, right? And so we start with our equation, k equals 1/2 mv squared, and we're going to solve this for m. So mass is going to be, first we're going to divide by 1/2, which is the same thing as multiplying by 2, and then we're going to divide by v squared. And now we just plug in numbers. 2 times 15,000 divided by 5 squared, and we find the mass of the boat is 1,200 kilograms, or 1,200 kilograms. Okay, so in the next video, we're going to look at the connection between work and kinetic energy, and something known as the work energy theorem.